Well, hello, Internet, and welcome to my Solidity Learn in One tutorial series. Well, this is going to completely cover Solidity in this one video. Okay, so we're going to be coding along, and you can feel free to ask me any questions that you have. Basically, Solidity is a language. I've been requested to do this by many people. That's why I'm covering it. Solidity is a language you can use to create smart contracts. And you may say to yourself, well, what's a smart contract? Well, basically, a smart contract is just a program that runs, in this situation, on the Ethereum blockchain. And they can have a balance and... Hey, thank you for stopping by. Kanan, is that how you pronounce it? Thanks for stopping by, dude. They run on the blockchain, and they can have balances, and they can handle transactions, and they're commonly used to ensure payment based off of certain conditions or imposing penalties based off of certain conditions, but they can be used for a plethora of other things. Now, I don't want to talk that much about blockchains and such because I'm kind of guessing if you're watching this video, you've probably heard of it. All right, there you are. Okay, cool. I got your name right. Basically, a blockchain is essentially just a database, just to keep it very simple, that stores transactions. Now, when we add to the blockchain, that transaction's going to be time-stamped. And we can only add to the blockchain and not delete, but we can sort of update information. However, whenever we do update information, we're going to create a new hash to represent, or a new address to represent that block of information. Now, each block is going to contain data, and the hash for the block and the hash for the previous block of data. So it's sort of like a linked list. And in this situation, the hash for the previous block is going to represent the chain for the blockchain. So hopefully that makes sense. The hash is, of course, going to be unique, and it's used to identify the block and its content. And I don't know if I really want to go into how blockchains are protected. I'm not going to go into that unless you ask for it. If you say, well, how do they protect it? I'll talk about it, but otherwise I'll just pass on that. The Ethereum virtual machine is going to be the runtime environment for our smart contracts, and they're going to be isolated, and depending upon certain conditions, they're going to have limited access to other contracts and limited access to outside sources. And we can make smart contracts and deploy it and do all sorts of crazy stuff. All right, so what I'm going to do is I'm just going to jump over and let's just bounce over here. Okay, so here we are. I'm going to be coding everything. Everything's the same on every OS because we will be coding in a browser. And to get to where I am, you just go to remix.ethereum. Did I spell that correct? Yes, I did. .org. All right, and you're going to be able to use exactly what I'm using right here. Okay, so that is the site we are using. So I put just a couple little pieces of information in here just to get started. First thing, you're going to have to always have a license. And you can see here I have a MIT license defined, and that's going to be the first line that you have. This is how you make comments. Now you can use multiple different types of license, or you can say that you don't want to use any license. In that situation, you would just type in unlicensed, exactly like that. GNU license, you could say GPL-2.0- and you can also stack licenses. This is a dash like that. We're also going to be able to use an Apache license, so you could say Apache -2.0, and you could stack licenses, so you could say or MIT in this situation. And of course, that information right there is going to go where this is right there. That's basically all you need to know about licensing. Then we are going to come in and we need to declare the compiler version that we are specifically aiming at. What's the prerequisite for this? Pretty much nothing. You don't need to know anything. I'm going to cover absolutely everything. It's pretty simple. There's a couple weird things about Solidity, which we'll get into, but I'm going to provide numerous different examples, so you don't need to know anything, really. This is definitely a newer language that is in very high demand depending upon a number of requests I have received. Okay, so here what we're doing is just declaring the different Solidity compiler versions that our code is being aimed at. So we could say greater than or equal to, and this is sort of arbitrary. I'm going to say 0.7.0, and so that's going to be our minimum, or less than 0.9.0, okay? So these are the compilers that we are mainly aiming at, and 0.9.0 doesn't even exist, so we know we're okay there. Also, it's important to know that you need to end all of your statements with semicolons. This guy right here is just a library that I'm going to use to be able to convert from what are called uints, or unsigned integers, to strings. So you're going to see that in a little bit. And I'm just going to jump in and just show you how simple it is to create a contract, and we'll cover everything. So let's say we just want to create a contract. So let's call it test contract, and this is kind of based off of C++, so you're going to see curly brackets and such. I'm going to get a drink here so I don't lose my voice. All right, so what do we talk about first? Well, we talk about variables, of course, and I'm also going to talk about data types here at exactly the same time, because that makes sense. So let's just create a couple variables, and I'll change the scope or the accessibility of said variables, and then I'll explain what all the different parts mean. You're actually there's a large number of variables, but you're going to notice there's one variable that you see in almost every programming language, or a data type, that you're not going to see with Solidity, and I'll explain why. So let's create a Boolean. Okay, and a Boolean can either have a value of true or false. So let's say can vote is what we want to signify here, and it can either be true or false, exactly like that. Another variable, we can use just basic integers. So that would be signed and unsigned integers. And let's mark this as private. Again, after I go through all these, I will explain exactly what the private and public and how that changes everything. So let's say I have an age here, and I want to keep that information private. We're also going to have uints, they're just unsigned integers. So uint, and I'm going to mark this as internal. I'll explain it in a minute. And I'll have favorite number, and let's just say that that is 3. And also we have strings, and I'll just have this be my name is equal to and Derek. All right, so there we go. We just created 4 different data types, and I'll explain exactly what is going on with said data types. Okay, so your variable names need to start either with a letter or an underscore, and then they can contain numbers thereafter also. You're going to have things that are called state variables, and they are values that are going to be permanently stored in contract storage, and they're going to be available to every single function in your contract. So all these guys right here would be considered state variables. You're also going to have local variables, and that just means they are variables that are created inside of a function, and that's it. They're not accessible outside of the function. You're also going to have, this is going to be also a little bit strange, global variables. And what a global variable in this situation is it provides information about the blockchain, and they are built into Solidity. You're also going to have a private variable right here. You can see that this is marked as private, and it can only be called within the contract. So that is the way that that works. And what else are we going to do here? Oh, I'll explain how uints work. So a uint is going to be by default 256 bits. You can, however, have a 8-bit uint, again, unsigned integer, and then they're just going to increment by 8. So the next size up would be uint 16 all the way up to 256. Now, if you need something that is bigger than 256 bits, you're going to have to use an outside library. Another thing you may notice, there are no floats. Why is that? Well, Ethereum is dealing with financial data. floats are not accurate. Financial data has to be accurate. So if you want to, or you absolutely must use a float in some situation, then you are most definitely going to have to use an outside library to do that also. Internal, I have this marked as an internal variable here. That is only going to be accessed in the contract or by contracts that inherit from it. What you meant by float isn't accurate. What do you mean? A floating point number? Not sure what you mean by that. You can emulate floats inside of Solidity, but there is no float data type inside of Solidity by default. That's what I meant to say. Okay. What else is there? Is there anything else? I think that's basically it. Okay, so I'm going to create what is basically just a default constructor. I'm going to get into the complexities of constructors and as the tutorial continues here. There's just so many things to cover. There you are. You just created a default constructor, and they're just going to be used to initialize variables. And like I said, I'm going to cover that at a later point. Another thing that's important is understanding the concept of casting from one data type into another type. All right, and yes, there is no default float type in Solidity. So I'm going to show you here an example of how big these numbers are. So here's UINTs, and you can see 256, and this is a big number. All right, so that is the default UINT whenever you create a UINT. Now, if you create a UINT 8, this is your max number, and you can see, and it just continues to go upwards from that point on. Now, we convert by basically just putting the value inside of parentheses. So let's just get rid of this because I'm trying to maximize my screen real estate here. So let's say you have a UINT that is 250. Well, that is going to be way too small because we want to try to minimize our overall footprint on the blockchain. So we're going to want to cast this. So how do you cast? Well, you just say what you want to cast to. And let's say that this is just the right size for the amount of data, the maximum amount of data we want to store. And then you just say UINT 8 like this, and then put too big inside of it right like that. There you go. That's how you cast. I'm going to show you how to cast using strings later on, but if you just want to convert between these basic integer data types, that is the way that you do it. All right, so let's just get rid of that also. I think you understand the concept there. Now, Ether is going to be the currency of the Ethereum blockchain. And you can see here it's just a couple different denominations of Ether and how they would basically relate to each other. And you can see here, the reason why we have such large numbers is because, at least when I'm filming this video at this moment, $1 is basically going to be equivalent to that much Ethereum. This is probably wrong now, but it's in that ballpark, all right? And that is the reason why we need many different denominations of Ether and why we have so many gigantic numbers whenever we are dealing with all of these different currency issues with Solidity. Now, a function is going to have a couple different formats. Let's go in here, and again, there's a lot of privacy information that is taken care of for us here. Oh, another thing I don't think I mentioned, whenever you create a new file, it is going to, so let's just say, let's say we create a function. Well, you would just come over here to tutorial like that, and then you would click right here to say that you want to create a new file. Here, I'll just do it, and I'll just call this section3.sol. The extension for a Solidity file is SOL. So there you are, and there you are. Okay, so didn't cover that. Okay, so whenever we're creating functions, we're going to first type in the word function, and we're going to follow that up with whatever your function name is. You're going to have a parameter list. You're going to define your data types for all of your different parameters inside of there, and you're also, in some situations, going to say that you want certain types of information to be stored in memory, also in there. I'll provide examples. You're going to have different scope, which I'll cover. You may or may not have returns inside of here. You will have returns if you're going to return information. And then inside of these parentheses right here, you will have the data type of whatever you are going to be returning. Thank you, Patrick Allen Games, for stopping by. And on top of that, you're going to have statements inside of parentheses. Okay, so that is the basic layout of a function. So I'm going to create a function, and then I'll show you how we can come in here and interact with the function. And of course, you're going to be able to interact with it outside of just the Remix IDE that I'm using here right now. Maybe let's get rid of this. So let's go and close that so that we can have more room here on our screen. So let's create a function. What do I want to do? Let's say I want to create something just very simple. I'm going to call it getSum, and it is going to receive two numbers, two uints, and it is going to return a uint. All right. So I'm going to say getSum, and I need to define my data type. So I'm going to say uint, and it's very common for parameters inside of functions to start with underscores. Doesn't have to be. It's just something that's commonly used. It's also very common whenever we have functions that are private that they start with underscores. It's just ways to very easily differentiate the different data types, or, you know, based off of their local or parameters or whatever in functions. Okay, so again, this is going to be public, and I'm just going to create this function, and again, I'll explain exactly what it means as we go on. Pure, you don't know what that means. Don't worry, I'll tell you in a second. And uint like this, and then what it's going to do is we're going to create a variable. Remember I talked about local variables? Well, here is a local variable. So I'm going to call this mySum, and we usually also use camel case naming conventions with variables whenever we're working with Solidity. So I went and created this. You can also initialize the variable right whenever you go and create it. So I'm going to say that I want to add num1 and num2 like that, and then I want to return my sum. So there it is, and there it is. You just created your variable. You feel free to go and code along with me as I do this. I obviously can't give you the code right now because I'm writing it, but after this video, sometime later in the day, I will post all the code on GitHub. You can download it. And of course, it's free. It's on GitHub. And so we're just going to do that. All right. So we went and got this guy. Now, there's a couple different things we can do. We can go and actually compile our code. But what I'm going to do is I'm going to deploy it inside of Remix, and I am going to just show you how it works. So what you want to do is you just want to select your contract that you want to deploy. Click on Deploy. And then you can come down here, click on this. And you can see right here, well, can vote, see, can vote is right here, and it is a public variable. So that data is going to be available to anybody who has access to the contract. And getSum, we could do something like 4 and 5, and then just click on getSum, and guess what? It's going to add stuff for us. And you can see we got a value of 9 returned to us after that. All right, and that is interacting with our functions directly inside of here. And there's also debugging. There is a whole bunch of different plugins. We'll get into more of this stuff later on. You can go and test your different contracts. There is information about gas. I'll talk about gas later on. And I think that's about it for now. So let's just go and close that. And let's create a couple more different functions. And if you're wondering, basically, this right here, term public, that just means, I can leave that there. Public just means that these are going to be, your contracts are going to be accessible by other contracts. If this was marked as private, then it's only going to be accessible to code that is in our contract. And like I said, private functions normally start with an underscore. If this was private, it is not. External, there's multiple different scopes so you can define inside of here. External functions can't be called by the contract, but can be called outside of the contract. Internal functions are only accessible within the contract. or by other contracts that inherit from this contract. You can sort of think of a contract as like a class definition in the world of object-oriented programming. Now, what does pure mean? Well, you're normally going to see one or another word here. You're either going to see pure or you're going to see view. Now, if this is marked as view, that means that it's going to work, this function is going to work with data and allow us to view the results of the function. However, it won't modify our state. When it's marked as pure, that just means normally that you're performing a calculation inside of here and providing a return. See, I'm not doing anything with state variables. I'm not doing anything with these variables up here. Everything is self-contained. It gets two numbers, it adds two numbers, it goes and returns a new number, and then it dies. Okay, all of these variables disappear. Their data does not exist after the function ends. If it is a pure function, that means that basically we're not dealing with state variables, anything outside of the function. We're only dealing with local variables. All right, so let's go, and is there anything else that I need? So you're going to normally use view if you're using variables outside of your function, and you're going to use pure whenever you're not dealing with any variables outside of the function. I think it's a nice, simple, easy way to understand that concept. So let's come in and let's create some more. Let's create another function. So we'll create a function, and I'm going to call this get result, and it is not going to receive anything. And I'm going to call this public and pure returns, and it's going to return a uint like that. And I'm going to create two new uints. I'm just going to call this A just for the heck of it, and let's create another one, and let's call this B equal to 5, and let's create another one inside of here just to create some different variables and get you acclimated to working with it, because you're only going to be able to really understand this language if you go in and type the stuff in, experiment. I'll get into looping and all that other different stuff. So you can see there you are. I just created another one. And there it is. And of course, if we come over here to this guy, you can kill these deployed contracts here just like that. Hit this and then come over here. And you can see get result. And 15 comes back because 10 plus 5 equals 15. All right. So basic math is also going to be covered in this tutorial. Let's go and show you another example here. I'm going to create a state variable. It's going to be a uint. I'm going to call this special value just for a reason. And there you go. So it's going to have a value of 10. Well, now what I'm going to do is I'm going to create a external function. And like I said before, external means that it can only be called from outside the contract, but not from within. So I'm just going to create a function like this, and I'm going to call it change sv uint underscore value external like this, and we can do something like special value is equal to the value passed inside of it. And let's create another function to help us along. I'm going to call this get sv, and it's also going to be external. Well, you don't put the external there though, you put the external here. And this is going to be a view. Can anybody explain why it's going to be a view instead of a pure? Let's go returns, if I can spell returns properly. Hydrate, yes, I do need to hydrate. We normally give variables. It's something that's sometimes done. Basically, it's just an easy way for us to know if a variable has an underscore that it's a local variable to a function. Okay, it's not something required. You don't have to do it, but it's a convention that some people utilize. Just like if a function is private, it starts with an underscore. It doesn't have to start with an underscore. It's just a very easy way to be able to see, you know, hey, that's a private function. Hey, that is a local variable because it has an underscore. That's it. It's not something imposed by the language itself. It is a convention that is commonly used with this language. All right. special. Nobody knows why this is marked as view instead of pure. All right. Well, let's go in here and we can just kill this like that. I think I typed everything in right. Just like this and like this. And you can see here we have change SV. So it has a value of 10. Let's change that to 20. And I'm accessing this function clearly outside of the contract. And then I can say get SV, and you can see that I got 20 back because I changed it up here. All right. Any reason to keep this? Not really. Let's just get rid of it and type in some more stuff. All right. So now I'm going to explain some more stuff about if you. Okay. So nobody knew the reason why that was view. Well, here I'll undo what I just did. Okay. The reason why this was a view instead of a pure. Pure. Look, we're working with a local variable, a local variable, a local variable, and same local variable and a local variable. Pure, we're only working with local variables. What changed down here? Why is this view? We are working with a state variable that's outside of our function. So that's the reason why we have to use view for that. I don't think I need get some anymore, so I think I'm just going to get rid of, well, maybe I'll just get rid of everything from there down, just so you can see the different parts of our function. All right. So let's get into actually working with math operators, and I'm also going to do some things with some error handling. List of stocks, run two strategies, Connor, okay. Okay, so you're referring to my previous stock market investing videos. Very likely that I'll make some more videos on that because it was a popular thing I did. And anytime something's popular and people request more videos on it, I make them. That's the only reason I'm covering Solidity right now is because I had a whole bunch of people telling me cover Solidity. All right, so I'm going to talk about math operators, and I also want to talk about error handling. So I'm going to create a function, and I'm going to call it do math. All right, so some good English there. And what it's going to do is it is going to receive a number. It's going to be an integer though in this situation, so it can be, we can work with signed integers, negative values. It is going to be public. It is going to be pure. So what does pure tell you? As soon as you see that, it should tell you a lot about what's going on. Let's get rid of that so that we can keep everything on the screen. Another thing, I do not see your comments. Why don't I see your comments? Oh, there they are. All right, so there is, I accidentally closed your comments there. I apologize for that. Let's go and verify that that works. Let's work. Let's go. Hey, look at that. Do comments work? And it popped up. All right, so I was just verifying that that actually worked. Okay, so I have a function called do math, and it is going to be a public function that is also pure, and it is going to return values. And what I'm going to do is I'm actually going to return 6 values from this. Can I do that? Well, obviously I can't. Otherwise, I wouldn't do it. Okay, so let's see if I can count to 6 here. Int. That's 6, right? Yes, it is. All right, so again, what do we need? It's a function, curly brackets. So there we are. We put that inside of there. And what I'm going to do, yes, Solidity is commonly, a newer language. So it is very common that you would not have programmed with it. All right, so let's talk about some error handling, because whenever we are working with math operators, error handling is going to be very important. I'm going to do something here. So I'm going to say require. And what do I want to require? Well, you could say basically what I'm going to do. Well, actually, you know what? First, what I'm going to do is I'm going to put the math functions inside of here, and then I'll do some error handling, because I think it'll make more sense. You'll be like, oh, yeah, that could cause problems. So let's say I create an integer, and I call this add equal to num1 plus num2. Okay? So pretty simple to add these values. And then we're also going to subtract values. So I'm going to just call this sub, just to keep that simple. So let's go negative, and let's also go in and multiply these different values. So mult is what I'll call this. And just these are just names. Sometimes people get confused and they're like, what? Do I have to type mult? No, you don't have. That's just a name. It's a variable name. It has nothing to do with a demand that you must name your variable mult whenever you're dividing or multiplying, whatever. Okay, you want to divide. There's that. Very important, especially in Solidity, is the concept of being able to calculate modulus, because we do not have floats specifically defined and as a data type. So there's modulus, which is going to give you the remainder of a division. And also let's just square this value, and how you do that, let's just take num1 and we'll just like that, and 2. All right, so there you go. That is 6 different values, and you can think to yourself, what sort of errors could I potentially have if I'm performing these different calculations? Well, I come in here and type in return. You want to return multiple values. You just go add and subtract and mult like this, and divide, divide, and modulus, and square. I got them all right? Yes. And then don't forget your semicolon at the end. So what sort of problems could we have with our values here that we might want to handle? Well, one thing is division by 0. And this is where we start handling errors. And there's a lot of other different things that could potentially cause problems. Okay, so let's say that we want to require that the second number cannot be 0 for us to be able to continue trying to execute code. Well, we can just come in and say require underscore num2 is not equal to 0. All right. And then if you want an error message to come out on the screen, you could say second number can't be 0. Like that, and throw in a semicolon. Now there's a couple different commands we can use here to handle certain different errors. Another one is assert. Now assert is also going to immediately end the function if a condition is it comes back as true, but it's not going to give you a message. So it's going to let's say we want to demand that num2 be greater than 0. All right, let's say these are uints and we do not want to work with integers or signed values. Well, assert is going to do that, but assert doesn't have a message associated with it. Now, revert has a message assigned to it, but it doesn't have the condition inside of it. So how you would work with it is you would say something like if, and this is doing exactly the same thing as assert is, because I didn't know what else to do. So I'm going to say if number 2 is less than 0. Well, in this situation, I want to call revert and put a message. And I'll say something slightly different. This is never going to be reached, by the way. I'm just showing you multiple different ways of handling different errors. And basically the way the errors are handled is the message goes out and saying why there was an error, and the program ends. All right, so there you go. Or not the program ends, the function ends execution. All right, so assert is going to be used if the condition is false. We're going to revert any changes that have occurred state-wise outside of the function. And it's also important to understand that it uses up gas. I'll cover what gas is in a minute. There's so many new concepts in Solidity that you can't really cover them all at once. Otherwise, it just becomes a mess of jargon. So I'll cover gas later. Just know that that's coming. Require, if the condition is false, we're going to provide an option, return a message. And it's going to refund any gas used. And revert only sends a message, and it must be put inside of a condition that is going to decide if it executes or not. Okay, So that is an overview. And like I said, after this video is over, later in the day, I will, inside here, I will post a link to the actual code so that you can download it on GitHub. All right, next thing. I have to get a drink. All right, so let's say we want to generate a random number. All right, let's see. How can we do this? Well, we'll just go function. This is along the lines of some stuff you would do if you were doing some mathematics inside of here. So I'm going to call this get rand number and uint and max. And I'm going to mark this as public. Now, as I do this, you should think to yourself, okay, well, he's marking this as public, and this is what that means. He's marking this as view, so we know what we can expect. It's going to return a uint. All right. All right, so how do we do it? Well, you can generate a Facado random hexadecimal using a hash. There's actually a bunch of hash functions that are built inside of Solidity. I'm going to use what's called kchac. It's like, well, why don't I just do it? So uint, and let's just call this rand like that. And I'm going to mark this. You have to cast this as a uint and see a k 256, and here I'm going to say ABI encode packed. And I need something that's going to be, you could pass a string inside of here, but I want something, and it would give you the same random number every single time. This is like a seed for generating a random value. But what I want to do is I want it to seem as if it's random every single time it's called. And to do so, I'm going to call a global. Remember I talked about global variables that are based off of the blockchain? Well, here's a global variable, and it's called block.timestamp. And that's going to change every single time time changes. So that's going to give you the idea that this is a random value. However, it's not really random. Okay. Another thing we can do here is, see, we have max inside here. This is representing the maximum largest value we want to be returned. Well, to get it to return nothing above that value, we're just going to take rand and we'll say modulus underscore max, exactly like that. And there we go. Okay, so basically kchac, this is this guy right here. It's going to take an input and convert it into a random 256-bit hexadecimal number. And this little guy right here is going to perform packed encoding of the data before using it to generate the random value. It's just something that must be done. And it's going to be based off of whatever the current timestamp is, which gives the illusion of getting a true random value. However, if you call this function 2 times really quick, there's a good chance you're not going to get a random value out of it. And we can test it. So let's go and let's do that. So we can come over here, we kill this, and test contract. We're still in this. Deploy. I don't have any errors. Let's come down here. Get random number. Let's say we want something that is up to 100. And I'm on purpose going to hit this twice quick. See? And you can see that I can basically get the same value 2 times. I don't know if you can see, but that's what I'm doing. If you click this function multiple times, and you can see also that it's not generating values that are over 100, because that's what the modulus function does for us. It's really awesome. Okay, so there you go. That is how you generate random values inside of Solidity. What else would we like to do? Well, let's talk about strings after I get a drink. All right, so I got a drink. So our strings, and I'm doing this all inside of this same contract right here. It's just like a class function in any other object-oriented programming language. And some people don't like to refer to Solidity as an object-oriented language, but it kind of is. It's just contracts, but whatever. Okay, strings. So basically, it's just ASCII characters between either single or double quotes. That's what strings are. Let's create a string. And there's tons of libraries outside of the core language that allow you to manipulate data in different ways. But I'm going to show you some libraries but I'm also going to sort of stay with the core Solidity language. Now, there are tons of escape characters you're going to see here. So let's just put them in here so I don't have to type this. There you go. So, you know, new lines, backslashes, single quote. Whenever you want a single quote to appear inside of a string that is surrounded with single quotes, that's what you do. You have returns, tabs. You're also going to be able to use hex codes and Unicodes inside of Solidity. So, you know, a whole plethora of different escape codes that are available to you. What else are we going to do? Well, let's create a function, and what I want to do with this is I want to get two strings and I want to combine them together. I think that's an interesting thing to do. So I'm going to say function, and I'm just going to call this combine string, like that, and it's going to receive a string. Now here's something a little weird. You are going to have to type memory inside of here. And what memory does is it states that you want to temporarily store this string data. And memory, however, is going to be deleted after each function is finished with execution. And storage can also be used to store data between function calls. So you're only going to have to do this with strings and arrays and bytes. That's your main core, what you're going to be. You don't have to do this with uints or ints, just strings and arrays at this time. Just think about that, and I'll get into arrays here in a minute. Oh, but I actually have to define what I want my string to be. So there, what I want it to be called. All right, so let's continue on with this. So again, I have another string inside here, so I have to type memory again. So this will be string 2. And again, it's going to be public and pure, and it's going to return something. So I'm going to say returns, and what is it going to return? Well, it's going to be a string, and again, anytime you see string in this circumstance, you're going to follow that up with memory again. So what I want to do here is just combine these two strings. Well, way back in the beginning, basically, you're going to have to say return like this. This is going to be a string, is what we want to be returned, and ABI, and you're going to say encode packed underscore str1, and then you're just going to, if you want a space between these, whoops, you do not want that there. You don't want this quote here. Well, actually, let's just get rid of this. Like that, and like this. All right, well, we can peep that. Okay, so we're going to have a space between our two strings that we want to combine, and then I'll have this like this, and then, of course, you want to have a semicolon at the end of it. And what is it giving me an error for? Return, you want to yell. Oh, okay, I'm missing a parenthesis here at the end. And it should go away now, I think. All right, what doesn't it like? String, memory string, unused function, parameter remover, comment, out the variable name to silence this warning. Oh, I see. I forgot to put an underscore here. Actually, very good at catching errors inside here. And this is just going to combine two different strings that are passed inside of it. So we'll just say deploy, and we will come down here and combine string, and I'll just say something like super, and awesome. I don't know, I'm just typing in random words and combine string, and you can see it did combine those two strings, and you got super awesome. All right, so what else can we do here? Let's bring this down here. You're also going to be able to work with bytes, and working with bytes is going to save computations versus working with strings. And so what I'm going to do here is I'm going to create a function. It's going to return the number of characters in the string. So let's just go function like this, num characters string memory like that, and str1. And I don't need to do anything else because all I'm doing is returning the number of characters inside of each of those strings. So it's going to be pure, and it's going to be returns, and it's going to be a uint. It was funny when one thing you'll get over is I always type in unit. I don't do it anymore because I've been programming with Solidity for a while now. But when I was starting off, I always typed in unit instead of uint. Okay, so if we want to convert our string to bytes, you can just say bytes and memory is equal, and what you want it to be called. So I'm going to call it byte1 is equal to, and then you can say bytes underscore str1 like that, and return byte1 dot length, and there we are. And the reason why I originally started doing this video is because I had a whole bunch of people say that they were being asked about Solidity in job interviews. So that is something, I guess, that is being brought up in job interviews. Hey, if you're like the only person that knows, if you have a room full of people and everybody has basically the same skill set and one person knows how to program with Solidity, who are you going to hire? And I think that's kind of the reason why. All right, so number of characters. Somebody says, I ate 2 burgers, they're delicious, but now my tummy's bloated. Okay. That's funny. All right, so number of characters, and I'll say, I'll just type in burgers. There you go. There, and we can just click on this, and you can see we get a value of 7 comes back, which is correct. And there that is. Thanks for the input. So up next, what I'm going to do is talk about conditionals. I can get rid of a lot of this stuff. Might as well keep this nice and clean. All right, I'm back. All right, thank you to everybody that stuck around. Thank you for Chameleon for the nice comment you posted. I greatly appreciate that. It means a lot. It means a lot to me. Like, I read all my comments. I don't know. I have a fairly large YouTube channel. And I read all my comments, and I know a lot of people say they do that, but I actually do, because, and I can prove it because I reply to every comment I get. So I really do appreciate all the thank yous. It just gives me a reason to continue making videos. If you wonder why I make videos, that's the reason why I make videos, because I think I help people. So that's the only reason I do it. All right, so what do we got? We have conditionals that we want to work with next. I'm very proud of myself that I went and turned my microphone on. Okay, so let's go. Conditionals. Well, we have comparison operators and logical operators. They're pretty much the same as other languages that you have dealt with. I am assuming Solidity is not your first language. So, okay, let's create another uint. And let's have our age be equal to 8. You're going to see that you can do pretty much anything you can do with other languages with Solidity. And Solidity can be even stretched out there even further and used for other capabilities other than just contract transactions. It can be utilized to create, people have used it to create like backends for games, a whole bunch of things. Okay, so let's just create a function here. What this function is going to do is it is going to take this is a hint for what's coming up. It's going to take this state variable age, and it's going to define what school someone would go to. So I'm going to type what school like that, and I am going to go and mark it as public. And what am I going to do? Am I going to type view, or am I going to... Oh, whoops. You know what? Yep, share screen. Thank you for stopping by. Yes, I make errors every once in a while. Okay, so here's your comparison operators, and here's your logical operators, all right? What I did was I created a uint that has an age and a function. It's called what school, and it is public, and it is going to define what grade a student is going to go into. So, it's public. Is it going to be a view function, or is it going to be a pure function based off of what I just said? It's going to be a view function, and the reason why is it's using an outside variable. And it is going to return something. What is it going to return? It is going to return a string. And what do we need? What is the special thing that we have to type in with our return values and our parameters whenever we're working with Solidity? To store information in memory. Oh, a big hint. Memory. Okay, so there it is. All right, so what are we going to do now? So what I'm going to do is I'm going to say if the age is less than 5, what I want to do, we're going to use curly brackets again. I am going to return the string stay home. And I'm going to end that with a semicolon. And let's just jump into else if statements. Of course, if you don't have any other conditions, you don't need that. So let's talk about how we can use our comparison operators and our logical operators all at the same time. Well, we're going to say age is greater than or equal to 5, and age is less than or equal to 6. If those conditions are both going to be true, we're going to return the string go to kindergarten, like that. There it is. Else if, and we're going to also stack our conditionals with logical operators. And we're going to say if the age is greater than or equal to 6 and the age is less than or equal to 17, well, in that situation, I need to perform a calculation to figure out a grade. So I'm going to say uint, and I'm going to define a grade. Remember, that underscore there with that variable doesn't need to be there. It's just there to sort of guide you in regards to reading code and understanding that that is a local variable. So we're just going to take our age minus the number 5. And what I need to do now is I need to convert my uint into a string. Okay? So I'm going to, and I've never done this before, I don't think. Well, to do this, you're also going to have to say string followed with memory. Again, because you want to store this in memory. And I'm going to call this grade string, and it is equal to, and if we want to convert this grade uint into a string, we are going to type in strings dot to string and pass in grade. Now make sure you have the one library that I have included inside of here. Then I wanted to concatenate these two strings. So I could use my former function I used to concatenate strings, but in this circumstance, I'm just going to do everything here right now. So we're going to say encode packed and grade, like that, and then follow that up with grade string, like that. And let's move this up here so that you can see it. All right, because my big head's in the way. All right, so that is going to return those strings. And then, of course, else you're going to have a default value if none of the other ones are true, and it is going to be return go to college, just because we're sending somebody to school somewhere. All right, what does it not like here? It says grade string, grade string. Oh, I forgot a parenthesis again. And there it went away. All right, I can kill this, and I can run this, and then I can come down here, and I can say what school, and it says grade 3, based off of the age being 8. And there you are. I need to run a minute. Will this stream be available? Yes, this is going to be available on Twitch afterwards. I'll make a highlight so that it sticks around for forever. And I'll probably do an edited version that I put on YouTube also. So, yes, all of the above. All right, so there you go. That is conditionals, and I think based off of that, you can sort of get an understanding of how we will utilize them to do all sorts of different things. So there we are. Sure, thank you, Wheeler, for stopping by. I greatly appreciate it. Okay, I love this back and forth sort of talk, and that's the reason why I like doing these live streams like this. But yes, I will also put an edited version of it on YouTube. And also, it'll be here on Twitch as a highlight that'll stay around as long as they'll let me. Okay, so now what we want to do is we want to start working with arrays. Now, to create an array that holds a dynamic number of values, so you can have any number of values inside of it, you're just going to type in, let's say it's you can have anything you want inside of these arrays, but I'm just going to have a uint inside of it. And whenever I define this, I'm just going to not give it a size. There you go, you just created a dynamic array. If you, however, do because we want to be very careful with the amount of space that we take up. If you only know that you're ever going to need 10 values, well, you just put 10 in there and that's the length. If you want to create an array of and also initialize values inside of it, you can say uint again, and in this situation I'm going to say public number list is equal to, and then I can throw a whole bunch of values inside here. So 1, 2, 3, 4, 5, that's good enough. And get rid of that last comma, and there you go. So now you have defined and initialized array, and yes, this is going to be 5 in value, and it's not going to be a dynamic array by default. Now let's say that we would like to create a function that's going to add different values to an array. So I'm going to create a function, and it's going to add it at the end of our array. And this function, you're still working at 1 a.m. Boy, that's a long time to be working. I do the same thing, so I completely understand you. So this function is going to add values to an array. So I'm going to say uint and number, and we will say public, and there we are. And we're going to, like I said before, add them to the end, and we're going to use this dynamic array here that we can continue to add to. So we'll say array1 and push, and number is what we're going to push onto it. And let's continue adding some additional functions that allow us to manipulate our array so that we can sort of, let's say we want to remove values. So to do that, we can say function, and I'll call this remove from array. And it's not going to be passed anything. It's just going to go and remove the very last value inside of our array. And to do that, we just say array1 and pop. And there we are. We just removed that. What are some other different functions we could do? We could say that we want to get the length of our array. So I'm going to say function, and I'm just going to call this get length, and it's going to be public, and it's going to be a view. I think you should, I think basically every single concept I've covered for the most part, just because I've reiterated it over and over again, and I think you should understand the concept of pure and view and private and all of those other different things. If you want to get the array length, you just type in array1 dot and length, right like that. Whoops, you don't need that. There we are. And that's going to give you your length. Anything else I'd like to do with these guys? What's cool? What happened if age will be 6? Will it be grade 1? Let me see if I have that. What's school? I had a question about this function. Let's just throw it back up here again, just to look at it again. Okay, so if the age is 6, what would it be? It would say go to kindergarten. See? Oh, you know what? Well, let's run it. Yeah, I was just throwing it. You have to understand, I'm just sort of throwing ideas out here, and there is a chance that I make a logical weird mistake. So let's throw 6 inside of here. It's going to say go to kindergarten because it meets this condition right here. And as soon as it meets a condition, it's not going to continue onwards from there. So let's just go get this, and let's kill that, and let's redeploy, and 6 is inside of there. And we'll go like this. And what's school? See, go to kindergarten. See, it met this condition, so it's going to say go to kindergarten. Of course, you could change this to less than 6, but just based off of the weirdness of my brain, that's just the way that I wrote those conditions. So yeah, if it that was actually a great question because it reinforced the concept of if one of these conditions is true and a condition after it is also true, because you can see I also have greater than or equal to 6, what's going to happen? Well, it's only going to fire the first one and then stop asking questions. So yes, that is a great question, and thank you for asking it, because that's something I should have brought up myself. Okay, so there you go. Anything else I would like to do? Well, let's say inside of your array, you would like to set the index to some value. Sure, thank you for asking me that question. So what I'm going to do is I am going to go and create a function, and what it's going to do is it's going to set a value at a specific index to 0. I assume if you're watching this video, you know what an index is in regards to an array, so I'm not going to waste your time explaining all that. Okay, so we're going to say function set index to 0 uint index, so it's going to be passed an index, and we're going to say public, and I can just simply come in and say delete array1 is what we're working with here, and then we're going to say whatever the index is, and that is going to work. And actually, you know what? I'm going to continue adding some additional functionality here and also explain for loops before I run this, because it's going to make for a better concept. All right, so what I want to do with a for loop is I'm going to go and actually show you how to remove indexes and then move values up. Because if I do this, I set index to 0, that's the way delete works. It says, all right, so let's say you wanted the one index of your array to be deleted. It's not going to actually delete that value and move the array up. What it's simply going to do is, if you say you want to delete index 1, it's going to put a 0 at index 1. It's not going to literally delete it. So what we would prefer to do, well, we can still do what we'll put a 0 there, but what I think is more beneficial is to be able to go into that index and literally delete it, get rid of it, pull it out, and then move the values up as if it never even existed. And I'm going to use a for loop to be able to make that happen. Now I'm going to create another function, and I'm going to call this remove index, and it is going to get an index passed inside of it, and I'm going to name it index, otherwise causes confusion. And we're going to make this public also. And to move that out with a for loop, you type in for, and then you are going to initialize your index. In this circumstance, I'm going to have my index be I, and I'm going to initialize it with whatever the value for index is. It could be, of course, index is what's being passed into this function. This could be 0, this could be 1, this could be whatever you want. I just want to start at where the index value is, because what I want to do is move all the values that come after the index upwards to make the value passed in disappear. So how do I do that? I'm going to say while I is less than and array1 length, and it's going to be array1 length minus 1, because these are inside of Solidity we use what are called 0 indexed arrays. Can you see this? Let's make that go away. So I just want to make sure. Whoops, well, that's not good. Here, hold on one second. Doing a interface change here just to make sure that everything is 100% readable. So I'm going to get rid of our chat box here for a minute, just because I think it is making it harder to see what's going on. So let's get rid of that. I can still see all your comments. They just won't show up on the screen here temporarily. Let's get rid of that. Let's get rid of this. All right. And let's go and reorganize this. All right. So I am going to remove index. So you can see that this is going to continue to loop as long as I has a value that's less than the length of the array, and the arrays are 0 index. That's the reason why we have to subtract 1 from the overall length. And then I have to finally define how much I want I to be incremented each time we loop through our for loop. And that's what that does for us. Now to get rid of that value at the array, I just say array1 I is going to be equal to array1, oops, I plus 1. Exactly like that. And then after I do all that, what I can do is remove the last item. So all the different values in the array are going to be moved one left from where they were previously. And then we're going to have a duplication, if that's true, at the very end of our array, and we're going to delete it. How are we going to delete it? Well, we are going to say array1 and pop right like that. And that's going to remove the last one. Let's do one more here before we run everything. And this is just going to get all the values for the array so that we can just go in and understand that things are working right. So I'm going to call this get array values and public view returns. And if you want to return an array, and you just type in whatever the data type is, you put your brackets inside of there representing a array. Remember I said anytime we're dealing, again, in parameters or in return values inside of functions, we're going to use memory if we're using strings or we're using arrays. And there we go. And I can just say return array1 like that. And I think, is that like everything that I want to do? I think that is basically everything that I want to do. So let's just do that. And then we'll go through and we'll sort of run all of these. So I don't have anything here. I'm going to deploy this. And you can see that it looks like it worked. I don't see any errors anywhere. All right. So what we're going to do first is we are going to add to our array. And it's going to receive individual values. So I'm just going to keep it simple. And remember, we're adding it to this dynamic array called 1, or whatever you want to call it. So I'm just going to go 1, add to array, and 2, add to array, and 3, add to array. Don't want to do any more. Let's do 4, add to array. All right. And then you can see get array values, and you can see that we got 1, 2, 3, and 4. I hope you can see that. That is what is being returned from that. And then let's go in and play around with a couple more of these. Let's call remove from array and get array values, and you can see the 4 is gone now. If I want to get my length for my array, I can say get length, and it comes back as 3. Well, I have 1, 2, and 3 inside of it, so that makes sense. If I want to set a specific index to 0, so set index to 0, and let's say that we want to do 2, get like that, set index to 0. You're actually going to see that the length does not change. See, still stays as 3. And get array values, you can see the second index, see, 0, 1, 2. The second index is, or the third index, but it's actually the second because it's 0 indexed, is going to be 0. And then if we want to go and remove a specific index, let's say we want to remove the first index like this. So I'm going to say 1, get array values, and you can see the 2 disappeared. So all of our code is working beautifully, and pretty good stuff. All right, so let's get that out of there. And what do we want to do next? Well, what else do I have here array-wise? Oh, I have a number list. Let's say we would want to cycle through the different values inside of our array and sum all of those values. Create function, sum, nums, and we're going to go public view returns uint, and there you go. And I'm just going to create a uint inside of here, and sum is equal to. And if you have any questions, you can still ask them, even though they're not. Oh, here, let me just pop them back in. Let's pop. Well, I'm just going to leave them here. Okay, so the comments aren't going to show up on the screen, but I will see them. So feel free to ask me questions. All right, so what are we going to do here inside of this? Well, I'm just going to create another for loop, and it's going to be a uint I is equal to 1, I is, less than or equal to number list. This is that list that's above, and length, in this circumstance, and I'll say I plus plus, and there we go. Whoops, accidentally hit that twice. All right, so I'm going to accumulate all these values. Oh, and you can also use a shortcut for adding a value to itself. Hydrate, I will gladly drink again. Thank you very much. Yeah, I have all these weird commands built in. If you type in, I don't know what they are. You get COVID points, that's what I call them. And hydrate again. All right. Hydrate more. I'm gonna run out of tea here in a minute. Okay. So there we are. So I'm gonna go and get all the different values inside of here, sum them. And like I said, this is exactly the same as if we said sum is equal to sum plus whatever number list it. Here, I'll say number list. I'll just type it out. Okay, it's just an abbreviated version of that. You can also do it with modulus and subtracting, multiplying, dividing. That shortcut is existent there. What kind of tea are you drinking? It's green tea. That's the only thing I drink. I have this weird problem where I cannot drink coffee. If I drink coffee, I fall asleep. It's like the opposite reaction to what happens with most other people. Not immediately, but soon thereafter, coffee makes me fall asleep. So if I want to stay awake, I don't drink coffee. Yes, it's matcha green tea. That is exactly what I have. So yes, I love it. I drink it like crazy. All right, so let's just verify here that I'm not doing anything wrong. Matcha green tea is fantastic. Yes, and I put a little tiny bit, like a teaspoon of vanilla syrup in it. Like, it's little. Less than half a tablespoon. And then I put in some almond milk. Again, like a very, very small amount. Like probably an eighth of a cup. I don't know if you want to know the specifics. Isn't green tea bitter? I don't think so. That's all I do. I love coffee, but I just can't physically drink it. It's like my favorite thing on earth, but if I ever really, it's funny, like me drinking coffee is almost like somebody drinking alcohol. It just totally puts me asleep. Within a half hour after drinking coffee, I cannot stay awake. Okay, so that's going to sum all those values, and then you learn something weird about me. There's plenty of things that are weird. All right, so let's deploy, and there we are, and sum numbers, as long as I type that in correct, and it's built in there. Oh, whoops. Oh, sum numbers. I clicked on the wrong thing. Did I do something wrong? Yeah, it looks like I did. Or that might have caused a bug. Let me just verify that I didn't do this wrong. Okay, so public view returns a uint, and it's going to have a sum, and it has a value inside of here, and I less than or equal to number list length, and is there anything else that I'm doing wrong? Number list, okay, I call this number list, right? Number list. Oh, num list, did I call it? Yeah, it's called num list down here also. Oh, this is going to be -1 on that, and return sum. And there, that looks good. I think that looks good. I think that's what I got wrong. Okay, so let's get rid of this, and I'm saving it in between every single execution that I have here. And sum numbers, yeah, and you can see it comes back as 14. And if we come back up here, 9. Actually, it should be 15. Oh, in that circumstance, yes, I would not, because I have less than or equal to, I don't need this part. So just get rid of that, and everything is cool after that. All right, cool. So we got that, and so there is an example of how we can use a for loop to cycle through different values. Let's do something similar with a while loop. So come down here, and I'm going to call this just something similar. I'll call it sum nums2, and import this as public view returns. It's also going to return a uint like that, and we'll say uint. And if you've ever used for loops, you understand that the index that we cycle through is going to reside outside of your loop. And we'll also have our sum like this. And then we define our while loop with our condition. And the condition is going to be while I is less than the num list length, we're going to continue to cycle. And as we cycle, we're going to say sum plus equal to num list and underscore I to represent the different indexes of our array. And then we will also increment the value for I. And then at the end of it, we can say return and sum. And that is going to work exactly the same as our for loop worked. Okay? So I think it's a good representation of how looping works. And I think I can get rid of all this. And then what I'm going to do is I want to talk about structs. So a struct is going to be used to create a data type that has multiple different variables inside of it, and it's like a custom data type. So we'll say struct, like let's say that we wanted to have a storage of customer information. We think about all the different things you'd like to know about customers, like their name and the customer address. You can't type address inside of here. For Solidity, it's a keyword, so you can't type that in. And age. All right, so here's some things we would like to be able to store about our customers. And let's say that we would like to have a customer array. So we can have information on multiple different customers inside of an array made up of customer values inside of here. I'm going to call this customers like that. And then, of course, in Solidity, you're constantly going to be making functions to solve problems because that's the way the language works. So we will say function, and let's say we want to be able to add a customer. Well, we're going to get a string, and what do we do whenever we have an attribute that is a string? We're going to type in memory. Same thing we would do if we're working with arrays. I'm just going to type n for the name, string, memory also. We'll just make this CA for customer address, uint, and A is going to represent the age, and then I'll say public and curly brackets. All right, and then to add customer information, we'll just say customers dot push, and what we're doing is pushing this customer data onto an array, and we're specifically pushing the struct on here, which is customer, and name, the customer address, and the age. And there you go. That is how easy it is to go and throw these customer data into an array. Now let's say you wanted to get said customer data from an array. How would you do that? Well, let's go and let's just call it get cost like that. And what we're going to do is we are going to use an index. So they pass in some index value. And of course we could cycle through these array values just like before and check for age or name or whatever you want to check for inside of it. So I'm going to have this be public, view, returns, string, what are we going to type? Memory. And this is going to be n, and then we're going to have string, memory, CA, uint, and A. Don't need to do memory for that. And I forget how to do line wrap on this. Probably the best thing. There, I don't need to do line wrap. I can just do that. And this is still showing up on my screen, right? Yeah. Okay, so there we are. Got all that in there. And to get our customer information, I'm going to say customer. Now in this situation, you have to type storage. Customer? Whenever you said uint, it sounds like yoink. Yoink. Yeah, I have a weird accent, so that's probably what you're hearing. It's uint. Unsigned integer is what it stands for. So, okay, so we have to store this in memory. And I am going to say customers, and I'm specifically going to get the index that they request, and then I'm going to say I want to return multiple different things, and the multiple different things are going to be the customer name. It's just a, oh, that's okay. You can't insult me, the dude. That's fine. I wasn't offended in any way by saying that it's my weird accent. I think my accent's a little bit weird. That's my own perception. Believe me, I've been making YouTube videos for like 30 years, or 13 years. So yeah, nothing bothers me, and I really very much like making these videos while at the same time having people ask me questions and make comments and stuff. It just makes it more interactive for me and less boring, because otherwise I'm sitting in a room by myself talking to myself, and in this circumstance I'm actually talking to people, and it's kind of interesting, and I really enjoy it, and that's why I make these videos. Okay, so there we are. I created a struct that has customer data, and I gave the ability to add customers as well as get different customer information. So if I want to run it, I can compile it. I don't want to compile it. Let's go and run this. Everything looks like it executed good. And here we are. So add customer. I'm just going to keep this extremely simple. So we have a name. I'm just going to call it paw. And I'm going to say what customer address. I'll just say Main for Main Street. And then age, I'll just put 20. And add customer. Actually, let's now do this. Okay, add customer. And then you can say I can continue adding customers, of course. And get customer, if I type in 0 inside of here, you can see that it returns all of that customer data also to me. So it's cool stuff. All right, boom. All right, so there we are. That is how to create a struct, and then how to store these different structs inside of arrays, and then how to go and get said data out of an array. So a whole lot of things. A similar type of concept is what we refer to as mapping. And what mapping allows us to do is to create key value pairs. And the key can be a string, a uint, or a boolean, and the value can be anything. All right? And how you define them is you just type in mapping like that. And then you define, okay, what data type is my key going to be? It's going to be a string. And what am I going to store inside of it? I'm going to store strings inside of it. That's the value. And I'm going to make this public. And I'm going to call it my map. Like that. All right, so what I want to do is I want to make a bunch of key value pairs that are basically superheroes. So I'm gonna have like their real name and their superhero name. All right, just as something to do. Hey, do any key value pair, any data type, anything you want. All right, so I'm gonna create a function that does this. So I'm gonna say function, and I'll say add super and string memory secret string memory name, and then let's make this public like that, and I'm going to just go my map, and here I'm going to have our secret. That is going to be our key, and the value I am going to assign is going to be the name, like that. Okay? And let's create a couple more functions. Let's say that I want to get a name from it. So it's going to return the value assigned to a specific key. So let's just go function, get name, string, memory, and we'll pass in secret like that. And this is also going to be public, and it'll be view. I hope you remember why it's view instead of pure. And it's going to return a string, and we're going to type in memory again. And there we are. Return my map and secret. Okay, anything else we want to do? Yeah, I think I want to delete names. So let's come in again and function, delete name, and it will be passed a string, and we'll mark this as memory, and secret, and public, and then after that, we can say delete my map, like that, and pass in secret. Exactly like that. I think that's good for just messing around. So we're going to come in here. We're going to deploy. And what are we going to do? I am trying to scroll. So I'm going to say that I want to add a super. So what should we do? Well, let's say I add Superman. And then I also add Clark Kent. See, that's what I mean, like what exactly that means. So there we go, and I passed that inside of it. There's Superman and Clark Kent, and if I want to get name, I put in the secret in this circumstance. So get name, Superman, like that. Run that, and you can see Clark Kent comes back. And then I'm also going to be able to come in and delete a name just by typing, as long as I type it in correctly, Superman, like that. And then if I go like this, you can see that nothing comes back. All right, there you go. That is basically how maps work. So pretty cool stuff. Then we have, you can combine structs with maps. So let's see, how do I want to handle this? Trying to think of an interesting concept for this. Well, I don't need this stuff anymore, so let's just go and get rid of that. Let's do customer again, because it's a pretty easy concept to understand. So let's just go and create a mapping again. Key value pairs. You're going to have a uint like that, and customer and customer, and let's see, can I get the customer struct that we had before? Let's get it, struct customer. So let's just go and copy this, bring this over here, boom, there we are, and save it. All right, so we have our struct that we have defined inside of here, and there is our customer. And what I want to do is bounce over here. I want to map customer data to a specific index in this situation. So I'm going to create a function. I'm going to call this add customer. I think I had an add customer before, so I'm going to call this add customer 2. Uint, and it's going to be customer ID and string, and again memory n, and I'll have string memory and customer address, and then I'm also going to have uint and age, and let's get rid of this so that it's easier to see everything on the screen a little bit better. And what do I want here? I'll say public and like that. And then what I can simply do is just type in customer, and I'll have the customer ID, and it's going to be equal to our customer struct that we've created, name, customer address, and age. And there we are. That's going to add our customer. And let's say that we also want to have the ability to retrieve customers. So I'm going to say function and get customer. I'm going to call this get customer 2 because I think I already had a get customer that was also set up inside of here. And I want to try to avoid messing up said code that may exist in the master cheat sheet that I create. So view and returns, and string is what it returns, and memory, and then this is going to be the name, and then also string memory, and this is going to be the customer address, and uint, and this will be the customer's age. And then what we need to return is going to be, I should have probably used something shorter than these gigantic long variable names, but it's going to be customer underscore index dot name and customer and index. Yeah, I should have just typed I. Why was I thinking? And whatever, customer address, and what else? Yeah, I definitely should have used shorter words. Customer and index followed with age, and there we are. All right, and then we'll talk about nested mapping after we do that. So that's going to allow us to go and create all of those creations. I'm not going to go into the specifics because it's very, very similar to what we previously did last time. So what I want to do, I think I'm going to go get myself some more tea. Basically, I take a break every 1 hour. All right, I'm back. The music I'm playing is during my breaks. Let's see if I can figure out what it is. It's something that's royalty free that I just found. I actually purchased it, but it was like really cheap. That's why I picked what I picked. What is it called? Let's see if I can figure it out. There's all my stuff. So let's see here. Can I figure out what it is? I'm not sure what it is. I'm searching. See if I can figure this out. It's called Motivational Dubstep, and it's from a website that is called, is it called, I'm not sure. Sorry, I'm not certain. I bought it many months ago for like $5. If you type in motivational dubstep royalty free, I bet you it comes up in a search engine. So hopefully that answers your question. Can you send yeah, I like dubstep. I'm kind of, it's my jam. I know it's not considered cool anymore, but I'm not considered cool anymore either. So I like really loud, fast music and heavy metal and stuff. If we lived in a world where I could use copyrighted music, this whole thing would be like metal and just crazy music. But we don't live in that world, or it would probably be like electronic house music is probably what I would play, because that's what I would like to play, but can't do it. Okay, so we talked about maps, we talked about structs, we talked about combining maps and structs. Now let's talk about what are called nested maps. Let's see, do I want to keep any of this stuff? Well, yeah, let's just keep it for now. All right, so let's bring this up here. And basically, nested maps are just maps inside of maps. Best followers, primes, and viewers on Mountain View. What? I don't know. Oh, okay. You want me to buy something, I guess. Okay, so if you wanted a customer list for multiple different businesses, and you wanted the businesses to have a unique ID, this would be a circumstance, for example, that you could use what is called nested mapping. And I'll show you what it looks like. Okay, so we'll have mapping, and then I'm going to use address. Remember I said address is a keyword? Well, of course it is, because everything is going to be based off of addresses. Anytime I say hash, I mean an address. And it's just a unique ID to represent your contracts and multiple other different things. All right. So then I'm going to say mapping. Oh my, that's terrible. I have never been able to eat. I never ate. Well, I did, but I haven't eaten regular beef for a long time. I grew up on a farm, so that just made me it always felt weird to eat the animals when I was a little kid, and that sort of just carried on to whenever I was an adult. So it's just like some weird thing I have. I don't have any problem with other people eating hamburgers, though. Eat it. If you enjoy it, eat it. I don't care. Okay, so there you go. We're going to have an address for each of the businesses, and then again, we're going to just be mapping another ID with our customers. And so let's say I want to map customer data to different addresses. I want to create a function that allows me to do that. Well, I'm going to create a function, if I can spell function right. So function, and I'll call it add my cus, like that, and it's going to get a uint passed inside of it that's going to be represented with the customer ID, and string, which is going to be a name, so I'll just call it N, and I got rid of all that. Yes, I did. Okay, and then I'm going to create another string, and memory, and CA for customer address, and another uint, which is going to be the customer's age, and then public, and there you are. All right, so I'm going to be using another global variable, and as this video series goes on, or this tutorial that we're watching continues, I'm going to talk about multiple other different global variables. Remember, global variables in the Solidity world refers to variables that are specific to data on the blockchain. And one thing you can do is you can ask for who called this function to execute. The message sender is what it's called. So what I'm going to do here is I'm going to say my customers, and then each of the message senders are actually going to be able to add customers, and it's automatically going to map all these new customers to their specific address. And I think you can see how that could be very useful in multiple different things. Like, let's say that we wanted to have a list of participants in a contract that are all represented by a unique address. Well, we could do that just like this. Okay, so customer ID. So there's the message sender would be the representative of all these customers, and then you'll have customer, and then you'll have information that's pertinent to that customer. You know, you might have emails or something like that. Contact information. There you go. That's all that function does. And of course, we could come over here, we get rid of this, we could redeploy. We could come down here and add my customers, and we could have a ID. Let's just have it be set to 1. We could have a name. Let's have the name be Bob. We could have an address. Let's just have it be Main Street. And then we could have an age, and let's just make it 50, and add my customers. And that information, you can see there's a check mark down there. We were able to add our customer information to it. Another concept that is very interesting is how time is handled inside of Solidity. Let's come out here, come out there. We have dates and times, and they're represented in very logical ideas. And what I'm going to do is just throw like an assert inside of this function. And remember, assert is going to cancel execution of a function if anything is untrue. So just to throw it into a function, I'm going to do that. So I'm going to say function and time units, and then I'll show you how the time units are equal to each other and how you can compare time units. So this is going to be pure, and let's just do assert, and we can say that 1 seconds is equal to 1. Okay, so the most basic time unit inside of Solidity is 1 second, and it's represented as just simply 1. Now you can see how all of the other ones are compared. So you have minutes, that is going to be equivalent to 60 seconds. And you could also put in 60 inside of there, or you could be even more specific and just put in 60 seconds. See, very easy to understand. 1 hours is equal to 60 minutes. And this continues onwards and onwards. Assert 1 days is equal to 24 hours. And you can see you always use the plural 1 days instead of 1 day whenever you're using these time units. And let's just do one more. We can say assert 1 weeks is equal to 7 days, and it continues onwards from there. Okay, so that's just a little bit of information about how time is used in Solidity. Another thing is what we call enumerated types, or enums, and they are variables that can only have a limited number of possible values. So for example, let's say you had a store or something and you had inventory on different shirt sizes. You could create an enum and you could have define its name as shirt size, and anything that would be of this enum type is only going to be allowed to have one of those values. Actually, you don't put anything after that. So what we can do now is we can come in and we could create a variable of type shirt size. So shirt size like that. And we'll say the customer has a specific size. Well, we could also come in and define, this is how you define constants in Solidity. So default, there we are, default, no, it's A-U-L-T, default. And if you wanted to define a default constant size, we could say whatever we want, but in this situation, we're going to say that medium represents the default shirt size. Now we could create different functions inside of it, such as picking shirt small, for example. And it would be different functions that are called depending upon, I just got a message that said Easter eggs have arrived. Okay. I don't know what that means. All right, so, and we'll say public. I guess my wife ordered Easter eggs. I say public, and then we could go and just define our customer size equal to shirt size and call small, exactly like that. And we, of course, we could do it for all of the different sizes. So let's just go like this, and you can see that we're very much working with calling specific functions to work with and change very specific values. And why you may ask, why would we even use enumerated types? Well, if there's only a limited number of potential values you can assign to a data type, it's going to dramatically cut down on errors. So if they try to order size extra large and you don't even have it, well, it's not an option. So it's going to immediately handle it, and through different error handling capabilities that I covered way earlier in this tutorial, using assert and require and such, you're going to be able to handle those errors directly inside of your code and not get as many unknown errors. And then you could come in and do something like get shirt size, and this is going to be public and view. And I think you know why it's view, because we're working with state variables or variables that are outside of our function. And return the customer size. All right, and there you go. And that is going to be able to go and work with those enumerated types and change to different defined values for shirt sizes for your customers. All right. Now, you're going to, I've talked a lot about the different special variables, and I'm trying to think if there's anything else that I would want to do. Something that is kind of common to do whenever you're working with message senders is changing balances and getting balances. So let's just get rid of this right here, like this. Oh, there you are. Let's put this down. Oops, I just deleted the whole thing. All right, make sure that you have your contract end with a closing curly bracket. Otherwise, you could have a lot of problems here. All right, so you know what? Let's do this in a separate contract just so we don't cause confusion here. So let's say that we have a contract and it's a ledger. So I'm going to go contract my ledger. And what is it going to have? Well, it's going to create a map of addresses and balances. So what are we going to do? Anytime it sounds like a situation in which we would like to have key-valued pairs. And addresses, well, that's a built-in data type inside of Solidity. And a uint, which is going to represent a balance. And this is going to be public, available to anyone who can access this. And it's going to be our balances. Now, what is common here is to be able to change balances for addresses as well as get balances for addresses, because in Solidity, these contracts can actually contain ether inside of them. Key value pairs remind me of, yes, it's exactly like a hash map. Yes, that's exactly what it is. It's very similar, just a different term. Okay. So we'll say we want to change balance, and we're going to get a uint, which is our balance that we want to change it to, and we'll make this public. And then what we can do is we can access all the different balances for our message sender. So this is who is contacting this function. And we can assign a new balance to it. And as you're going to see later on, there are specific ways to protect balances and things such as this from being manipulated, and I'll get into that later on. So it'll say, you know, these people can manipulate the values and other people cannot. And then if you want to be able to, say, get a specific balance inside of it, you can do so just by public and view and returns. And this is going to return a uint like that. And we can just say return balances and message and sender like that. And there we go. So that is how we could create a ledger of balances that are assigned to specific unique addresses. Just something that is very, very commonly done. Another thing that I'd like to talk about is the concept of function modifiers. I'm just going to get rid of this contract here altogether. I have all this separate. So you can have multiple contracts inside of each individual file as well. All right. So let's say we wanted to create a contract that will be inherited that contains a function modifier. How should we do this? I'm trying to figure out how exactly I want to explain these different concepts here to you. Maybe it makes more sense to actually come in and actually define what we need, what we mean to have different shapes. So let's, to have different contracts and then create those contracts and then inherit them. I'm going to cover that first. So where's that function? Okay, I'm going to do it over here. Okay, so here we go, and I went and put in our license, which we covered earlier, the compilers that we are aiming at, and then this library, which I don't even know if I'm using it right now, but it's there as it is. Okay, so let's say we wanted to create a contract which is going to represent a shape that is then going to be inherited into a new contract, and I'm using like real world objects this time just to change pace a little bit. So I'm going to say that I have a contract and it's going to be shape and it's going to be inherited. Well, what do we want to say all of our shapes have? We're going to say that they have a height, and we are going to say that they also have a width. So you can do non-contractual applications using Solidity as well. So, and we're going to create a constructor this time that's actually going to do something. Remember I said I was going to give you some examples where we had constructors that did stuff. So it's going to be passed a height, and it is going to be passed a width. Exactly like that. All right, then we can assign to the state variables the height and also the width is equal to and width. All right, so there that is. Okay, so we got our constructor, and that's just going to initialize those variables every time a new shape variable is created.
And we can close that like this. Now what we're going to be able to do is we can actually inherit from the shape contract, just like we do all the time with regular object-oriented programming. Okay, so what would I like to do? Well, let's create a contract here. And you can actually do some interesting things here. So I'm going to say that I have a contract called square. And to inherit everything that is in shape, you just say is shape, like that. And you're going to be able to actually call the shape constructor directly like that just by throwing 10 and 10 if that is the size of your square. But I'm not going to do that, so I'm just going to get rid of that right there. I just wanted to let you know that you can initialize calling this constructor right up here, the shape, which is the inherited from class, directly right inside of there. But I'm not going to do that. It's not very commonly done. It's just something I like to cover everything when I make videos, so I thought I would just cover it. Okay, so we have square is shape, and we're going to have a constructor inside of this also. And so we'll say constructor and uint h and uint and make this w. And if we want to call the shape, the inherited superclass's constructor, we can just go shape h and w, and it will automatically initialize everything for us. Now our shape in this circumstance is kind of boring because it doesn't really do anything, and our constructor in this circumstance actually is kind of boring also. I'll do another example later on that will show you a little bit more complicated things. Okay, so now we can go function and get height and go public like this and view, and this is going to return a uint like that, and it's just going to return height. There you go. And let's say that you'd like to do something else like get area, and I could actually define an area function inside of our superclass named shape that would then change depending upon what other contract types inherited from it. So every single shape has different ways of calculating area, and we could handle that just like we do with any object-oriented programming. That's why I don't understand why some people are like, Solidity is not an object-oriented programming language. Well, it kind of really is. So I don't understand why people say that, but whatever. People say things all the time. Okay, so we could just come in here, since this is a square, and we can just say that height times width, and there we go. And that is just a basic concept of how we can go and create these different types. All right, and then we could also come in, I have that selected, and we can come in here like this, and we could define a shape, but that's not really going to matter in this circumstance. So I'm going to go and get a square right here, and you can see here if we deploy that, we're going to have an error in this situation because we actually need to deploy our shape. So we'll go and deploy this by going and providing different values. All right, so we can either go and define shape with height and width, and what we're actually calling here is our constructor, and if we don't do that, it can't be deployed. So I can actually come down here and say that I want my square, and in this situation I will actually provide 10 and 10 as values for my constructor, and now I will be able to see, there it goes, and now it does actually create a square shape. So it literally will not allow you to create a contract unless the data for the constructor is provided. And what we can do is I can go get area, and it's going to have 10 times 10 equals that, or I can go and get the individual pieces. So it's very, very controlling in a good way as a language, because it's very easy to avoid different types of errors, because it literally just won't allow you to execute the code unless you follow the rules. All right, so you got the basic concept of how contracts work and such. So now what I want to do is I want to talk about function modifiers, what we were previously talking about before. And we're going to use inheritance again. So what I'm going to do here is I'm going to create a new contract, and I'm going to call this owner, like that. I am going to hold the address for the owner who deployed this contract. And what I want to do is I want to use function modifiers that's going to block execution of certain functions unless the entity executing those functions is the owner. All right. So this is going to provide a lot of power in regards to creating contracts that only the owner of the contract is going to be allowed to execute, and nobody else will be allowed to execute it. I have to get a drink. Okay, so we have an owner. We're going to define that. And this is going to be the address for our owner, like that. And what else do we want to do? Well, inside of our constructor, I want to set the owner as the entity that's going to, that did create our contract. So I'm going to do that. And you just saw that the constructor doesn't mess around. It doesn't let you do anything unless you provide said information. So I'm going to say constructor public, like that. And then I'm going to go owner is going to be equal to the message sender. So they're not going to be able to say who they are. It literally is going to get the address from the individual that contacted and created this contract. All right, that's where it comes from. So now what I want to do is I want to create a function modifier that will block anyone from changing prices except for the owner. And how you do that is you say modifier like that, and I'm just going to call this kind of convention to mark this function as only owner. And so we're going to call it only owner because everything else does. And then what we're going to do is use our require that condition, and it's going to be true, or there's going to be an error that is thrown. So I'm going to say require. Did I spell require correct? Yes, I did. Oh, no, I did not. Require. There we are. And message sender has to be equal to the owner that created the original contract. And if it is, we want it to allow it to execute code inside of a function. Now, this only owner is going to be used later on in our code. And how you designate that you want those who use this function modifier to execute the code that follows after is you put an underscore and a semicolon. All right, it'll make more sense whenever I run the code. All right, so what I'm going to do now is I'm going to inherit from owner. So I'm going to say contract, and let's say we have some type of a purchase is owner, and let's move this up here a little bit. And I'll make all the code available on GitHub later on in the day, so you can go and get it. I'm going to create a mapping again, and I'm going to create a map that's going to link addresses for purchasers. So this is mapping, and again, what are we going to be using? Well, we're going to be using address, and it's going to be marked as true if the purchase was made. So we're going to have like a list, and I'll say purchasers like this. Let's say I want to have like a price defined inside of here. There that is. I can create a constructor inside of here. And what am I going to do with my constructor? Well, it's going to be a uint, and it's going to have some price passed inside of it. And I'm going to set my price to be equal to underscore and price, like that. And what else would I like? Well, I'm going to set it so that you can call this function along with some ether, so that can be accepted. And how you define that a function will be able to accept ether is by marking it as payable. So I'm going to say function purchase, and there we are. So this is going to be public and payable like that. And, oops, did I spell function wrong? Yes, I did. Function, there we are. And there we are. Okay, so what we're going to do is, see, it's marked as payable. And I'm going to say purchasers, and we're going to use whatever the sender's address is to mark this information. and we're going to mark it as true. Okay, it could also be things like an agreement, you know, like you're signing a list, a group of people that have agreed that yes, indeed, they will follow these certain rules, or they will do certain things. Okay. All right. So now what I want to do is I want to create another function, and what it's going to be is a function that's going to set the price. But the issue here is we only want the owner of the contract to be able to set the price, nobody else. So we're going to say function set price, and it'll be passed a uint, and we'll just have it be underscore price like this, and this will be public, but we're going to use our function modifier, our only owner, and it's only going to allow people to access set price if they are the creator of the contract itself. And this right here is going to be the code that follows after the declaration for the function. That's what that stands for. And it's very simple. It's just one line of code, but there it is. Okay, so this part right here is equivalent to this, if that makes any sense to you. But it basically is just saying execute that code if the original contract creator is the person that is calling the function called setPrice and passing a price. Okay? And if we go and execute that, oh, all right, thank you. Thank you for the, you're awesome. Thank you there, Kanan. I have greatly appreciate you giving me some input here. All right. And, oops, I hit the wrong, I tried to deploy the wrong contract. Is this is going to be, is it my ledger? I forget what I called my contract. Contract purchase is owner. Where did I save this? It's test contract. I might not have saved it. So let's save it. All right. Oop, what is wrong here? Parser error, expected type name. That's my, I think that's my first error of this whole entire tutorial. What did I do wrong? Normally the errors are really cool here. Wait a minute. Yeah, this is not correct, is it? This is supposed to be, why did I type true inside of there? It's supposed to be bool. Yeah, you never do that. It's always data types inside of there. Okay. So I don't have anything down here. Yes, I do. I have this guy right here. All right. And this is saved. And let's see. What do we have here? We have our test contract inside of this. And this is this guy, right? Yes. Test contract and contract owner. And that is going to be this. This is interesting. Not quite sure why it is doing it that way. Maybe I should have these be separate because it looks like it's causing a little bit of confusion in regards to that. Well, anyway, that is going to allow you to create those contracts and then execute them depending upon the different addresses that are being passed inside of there. Okay. And that brings us to another concept. I keep talking about something called gas. So what exactly is gas? It's a fee that is going to be charged for executing a contract on the Ethereum virtual machine. So the cost is going to depend on basically supply and demand. And the price is normally going to be in Gwei, is the currency denomination in Ether. And anytime you hear somebody talk about gas limit, that's the maximum amount of gas you're willing to spend for a specific transaction. Okay, so that's like a brief. I mean, you're using other people's computer resources to execute your contract, and that in gas is what you are going to use to go and essentially pay for those things. Let me see what else. I think really I've covered so many different things. I think one of the only things I haven't covered is fallback functions. Let's come in here. let's get rid of this, and let's also get rid of all of the test contract and all this other stuff, because I think it's causing some confusion with these different things. Okay. Now, what is a fallback function? A fallback function is an anonymous function that does not take input nor provide output. It's going to execute if no other function matches the function identifier passed to our contract, or if no data was provided with a function call. And it also is going to execute when the contract receives Ether without data, as long as it is marked as payable, like we said previously. And I think that's basically everything you need to know about fallback functions. So I'm going to create a brand new contract here. So let's go contract, and it's going to be its own self inside of here. And I'm just going to call it, just for simplicity's sake, I'm going to call it fallback test, like this. And I'm going to create a mapping that's going to map addresses to balances. So I'm going to say mapping address to, and it'll be a uint and balance, like that. Okay. And let's say that I would want to trigger an event, and we would want to trigger the gas amount for this transaction. Well, how you create events is you just type in event, and it's going to be log uint, and it's going to have our gas amount. And let's create another function. Well, let's create our fallback function. And how you do that is you just type in fallback. Remember, it doesn't have a name. And then we will say external payable. It receives Ether, or can. And what it's just going to simply do, these fallback functions shouldn't do much of anything, like one line of code. So basically what we're doing here is we are just logging the gas left for this function. And how you do that is just say log. And again, here's a global variable called gas left. And it is going to just log that gas left that is available after it. And this is, I have a habit of camel casing everything. Gas left is just lowercase. Now what we can do is we can say function and get balance like this, and public, oops, put it in the wrong place, public view returns and uint, like that, and return address. And if you want to return the address for where this is running, you go address this and balance, exactly like that. And there we go. So that is how a fallback works, and basically allows you to receive Ether if a function is incorrectly called with the wrong name. Okay, it's sort of like kind of handles any type of an error. And what we can do also here is, let's create another contract. I think this is the basic. I've covered the whole core language at this point. I'm just covering some little weird things and just giving you an example. What I'm going to do now is I'm going to create a contract, and what it's going to do is send Ether to my fallback test contract that we have up here to sort of let you actually see the execution of this happening. Okay, so I'm going to go contract. Oh, let's get rid of this because this is taking up so much space. Okay, so I'm going to go contract, and then I'll work through the whole entire thing. So transfer to fallback. Oops, there we are, curly brackets. And I'll say function transfer, and I promise after you see this execute, it'll make more sense. So it's going to get an address and payable and target. So this is going to be a target address, and this is going to be public, like that. And this is also going to be marked as payable. And then what we'll simply do is say target transfer. And another global variable is message value, which is the value that is passed with this call right here. And then I'm going to create another function, and it's going to send ether. There's multiple different ways of sending ether. We're going to cover how to send ether using transfer and how to send ether using call. So I'm going to call this call fallback, and then you're going to see how it's going to be able to receive it with our other contract. And yes, and I'll just mark it also as target because that sort of helps. And public and payable like that. And let's come back here like that. And this is just the way that transferring with a call, using call works. You have to go bool and sent like this is equal to, and underscore target is just the name that I'm using. And then you say call, and you pass in value, and what you're passing in is the message value. And I'll show you how to pass in the values and where all that comes from. And I'm not going to put any message inside of here. I have to get a drink. Okay. And it'll make sense whenever you see it execute. Okay, so I'm going to say require sent. And in this situation, if it was not sent, I am going to mark, you could say anything like error or failure or whatever, and I'll just say not sent in capital letters because I'm so upset. All right, so there we are. Okay, so now that I have all that defined, what is this yelling about? Oh, okay, bool sent. Whoops, I didn't mean to put that comma inside of there. All my errors go away. Yes, I did. And I wish I could keep all this on the screen at exactly the same time, but can I get rid of this? Yeah, I think I can. No, I can't. I want to get rid of that. Oh, there it goes. Okay, so I have contract. Yeah, everything's on the screen at the same time, and I think you can see everything. Good. Okay, so we have our contract fallback test, and then we have our other contract, which is transfer to fallback, and it has two functions in it. One of them is going to transfer using the transfer method, and another one is going to be the call method. And I'm going to walk you through the entire process of executing all of this. And the code, I understand that, Kanan. Believe me, this is insane amounts of information all in one video. That's why I post on GitHub all the code, and then I heavily comment everything. So you'll be able to use it like a cheat sheet to sort of understand it. This is a complicated concept that most people don't understand. And I think that's why so many people are finding it valuable information to put on their resume because, there's not that many people that understand it. So good stuff. Okay, so what I'm going to do is I am going to fallback test. I'm going to deploy it. Okay, so I just deployed it. You can see it's down here. And then I'm also going to go and get transfer to fallback, and I'm also going to deploy it. See, I have both of them set up at the same time. Now what I want to do is I want to transfer using addresses. And so what I can do is I can click copy, see, copy and copy. I'm going to click copy next to the fallback test. And what this is going to do is it's going to copy the address. It's going to copy its address for this specific contract. And then I'm going to be able to paste that address into the transfer fallback. So I can come in here and transfer fallback. Here's the address I want to paste into it. So there that goes. And then what I'm going to do is I can define up here how much ether I want to pass in. So let's just go and give this like a value of 2. And we can change this to whatever we'd like. So I'm going to say ether right here. And this value is how much ether this is going to pass to this fallback function here and catch it. Okay, because it can't go anywhere else, so it's going to go there. And then I can go and transfer the that data. So I'll just go transfer fallback like this. Transfer. And then what we can do is go to our fallback test and go get balance, and you're going to see that we have 2 show up inside of there. So we were able to effectively create 2 contracts and have one contract send ether to another contract, and it was cut by the fallback because it basically is the default place that receives data. And you can do exactly the same thing with using the call method. So I just paste this inside of there and do call once again. And if we then go into balance, you're also, oops, yeah, I need to go up here and change the value here. Let's just change it to 3 ether, and you can see that I am able to transfer that information over. Let's just go call and then get balance, and you can see now we have 5 inside of there. All right. So I greatly, that is an overview of pretty much the entire Solidity language with numerous different examples. Thank you to specifically Kanan for sticking around throughout the entire video. You've been my buddy the entire time I've been making this video, and I greatly appreciate it that you stuck around and asked questions and were just an overall cool person. Thank you for that. You've reached the end, and after very, very soon, I'm going to post all the code with all the comments on GitHub. I will post the link to the code in here on Twitch. And actually, you know what I'm going to do? I'm going to do it right now. I'm going to, just so I can give you the link. Let's go here. And you can see I was looking up a recipe for making cabbage and noodles. Okay, so I'm going to go on GitHub right now. Oops. It's going to just, this is the location, but just understand, asset central. I'm just going to ignore that, and hopefully my whole entire computer doesn't crash. Is that going to work? I think it's going to work. Yeah, it's going to work. Okay. Okay, so I'm going to create a new repository on GitHub, and it is going to be called Solidity. I'm just going to call it Solidity. Why not? Okay, so all the code for my video, learn Solidity in one video. And I will create that, and I will, in the next hour, I will post all the code inside of it. So create repository, there it is. It exists right now. And in a couple minutes, I am going to actually post all the code inside of there. So let's go and get rid of that. Here is where everything is going to reside. I have to make sure I have comments set up. So I do not. So let's jump to like this. And I have my chat set up here, I believe. There we are. Chat box. And there we are. Boom. And there you go. So that is where all the code is going to go for this whole entire video, and it'll be up there in about an hour, I would guess, and everything will be ridiculously heavily commented. All right, so thank you to everybody who joined me and made this an enjoyable trip. Talked to me and such, so I wasn't so lonely. I appreciate all of you, and like always, please leave any questions or comments any place you can find, and otherwise, I'll catch you next time.